we have unit 2 twin, plus old stuff. What's the equation of a parabola in vertex form that has a vertex at negative 2, 4, passes through negative 1, 12? Your form is y equals a times x minus h squared plus k. That's the big deal, because that's what you plug into. This is h, this is k. This is x, this is y. We plug that in. So there's a y, 12 equals. I don't have a, it's nothing. There's an x, it's negative 1, minus a negative 2, all squared, plus 4. If you do the math right here, this is 1, and 1 squared is 1. So 12 equals a times a 1 plus a 4. We're going to subtract the 4, and there's our a value. Our a value is 8. So I'm going back to the form. This time I know a. A was 8, assuming I didn't make any mistakes. Times x minus a negative 2, all squared, plus k. So here's my equation. 8 times x plus 2, quantity squared, plus 4. I was hoping I could find a better ink pen, but I can't. The function g is a transformation of the mother function f of x equals x squared. G has been translated right 3 units and down 2. Write the equation for g of x in the form y equals ax squared plus bx plus c. So what we're going to do is we're going to start with vertex. Y equals a, and it doesn't say what a is, so it's probably just 1. Write 3 means we take away 3, plus k, which is down 2. And then we're going to write x minus 3 twice. We're going to FOIL, or double distributive property. Then we're going to put it all back together. Ta-da! Use quadratic regression to find the equation of a function that fits the points below. All right, so I'm going to go to Stat. I'm going to go to Edit. Stat, Edit. I'm going to clear out whatever I have in list 1 and list 2. And I'm going to push some stuff in here. My x's into list 1, my y's into list 2. This is one of those things that's really easy, but a lot of kids are just going to miss. I mean, a lot of kids are going to miss it because you just won't do it. And then I'm going to go to Stat, Calc. It said quadratic regression, quadrag, calculate. So I got an equation here. A is about 0.746. That's an x squared in the lineup. Plus B, which is 0.454x, plus C, which is 14.394. Now it says, after turning on diagnostics, find and interpret R. I've already done it on this one, but diagnostics is second catalog, scroll to diagnostics on. So second 0, and I scroll to diagnostics on. Press enter, enter, done. And I go back through that process, and if you didn't see it the first time, it'll be here this time. It told me that R squared is about 0.8153. So R is equal to the square root of 0.8153. So I'm going to quit out. Square root 0.8153 is about 0.9029. You're supposed to interpret this. Since the absolute value of R is greater than 0.8, there's a strong correlation. Ta-da! There we go. Identify the intervals on which the function y equals negative x squared plus 6x plus 16 is positive. I believe that thing will factor. Most of these do. So I'm going to go to y equals. Literally going to go to y equals, and I'm going to look at the graph. In other words, what they're asking you is, where is negative x squared plus 6x plus 16 bigger than 0? Because you're positive. And that's happening between here and here. That's happening so long as x is greater than, it's positive, not equal, negative 2, and at the same time, less than what, 8? Yeah. So as an interval, because they do want an interval, I am stuck between negative 2 and 8. All right. Write the quotient 34 over 5 plus 2i in the form a plus bi. What we do is we multiply the top and bottom by the conjugate, which is 5 minus 2i. We use the distributive property in the numerator. 34 times 5 should be 170 minus 68i. Down low, all that matters is first and last. 5 times 5 is 25. Positive 2i times negative 2 is minus 4i squared. And the deal on those was so I get 170 minus 68. 25 and 4 is 29. Don't forget about your I. I don't think that simplifies. You'd be an absolute idiot if you missed this on a test because you have a TI-84 in front of you. You go to math. You go to no. Get the up arrow. You type in 34 over 5 plus 2. And I told you I'd put one of these on here. They'll be missed. Ta-da! All right. Function is defined by the equation y equals x squared plus x plus 2. Find its domain. Just look at the graph, bruh. There's the graph. Literally look at graph. I don't think most of y'all can do this without looking at the graph. This thing is running left and it will always run left. It is running right and it will always run right. It is negative infinity to positive infinity, or all values of x such that x is an element of the real. Find the range. There's a low number right here. Range is y. I'm going to hit second trace minimum. I'm going to follow the instructions. I'm going to get left. I'm going to get right. That's the instructions, and I'm going to guess. That's negative 1/2. And that exists. And it rises both sides of the vertex to all infinity. Vertex form. That's not too hard. I know that h is negative b over 2a. So a is 1, b is 1, even though it doesn't matter, c is 2. So negative 1 over twice a 1 is negative 1/2. Notice the connection there? See how those match? K is found by taking your negative 1/2 and plugging it in. And that would be a fourth minus a half, which is negative 1/4. That's kind of hard to see, isn't it? Case and be complaining about my handwriting. That's a fourth minus a half, which is a negative half. Sorry, negative quarter. Plus 2, which is negative 1.75. If you're Tyler and like decimals, I really don't. I like negative 7/4. And now I have my stuff. By the way, a was 1. So y equals a times x minus h squared plus k. So y equals understood 1. Taking away a half is addition. Sorry, taking away a negative is addition. Then minus 7/4. Oh, and the function's minimum. This would happen at the vertex. It happens at negative 1/2. And its value is k, which is negative 7/4. We also did it up here. Remember me going through second trace minimum? I get left, press enter. I get right, press enter. Enter for a guess. 1.75. That should be positive. I'm glad I did that because I realized the mistake. That was positive. So I'm glad I did that and caught my mistake. All right. Now let's keep going. Let's get a little more of this done. But I am going to break it into two parts in case something crashes. Can't do much today. My wife is sick and I have to head home. So I'm just getting a couple of things done while I'm here.